Good morning, my dear students. Let's continue the chapter called Units and Measurements. In units and measurements, the concept we are discussing is dimensional analysis and their applications. In dimensional analysis and in their applications, there are four applications are given. Conversion of one system of units into other is finished. In this, what we had discussed. 1 joule is equal to 10 raised to 7 erg. 1 Newton is equal to 10 raised to 5 dyne. So those are the things we had finished in this first application. And checking the dimensional correctness of the equation is we are doing. And this is the second application is called as principle of homogeneity. What is it called? Principle of homogeneity. All right. And let's recall the principle of homogeneity. For your better understanding, I'll just revise for a few minutes. Principle of homogeneity. And before moving to that, there are other two applications which we have not yet started. Finding the relation among the physical quantities, designing our own system of units. Most of the times in NEET, JEE, CET exams, the question was asked on the principle of homogeneity. Next important thing, based on the designing our own system of units. First priority to be given while preparing for the entrance exam for the second application. So that's the reason, and two more classes also we will be discussing the principle of homogeneity only. And next preference will be given to this when you are preparing or when you are revising for the exam. And for the board exam, 100% there will be a question based on the third application. What is that? Finding the relation among the physical quantities by using the dimensional analysis. My dear students, I hope you all are ready to start today's session with principle of homogeneity. And this principle of homogeneity tells us that if I wrote x is equal to a plus b, this is an equation. Those are three physical quantities. X, a, b are three different physical quantities. Understand? According to principle of homogeneity, it tells two things. When you are adding or subtracting two physical quantities, there must be same dimensional formula having. These two must be having same dimensional formula. That is the first part of the principle of homogeneity tells. When you are subtracting two physical quantity, and let's say one more equation, I will write y is equal to m minus n. When you are subtracting two physical quantities, definitely those two physical quantities must have the same dimensions, same dimensional formulas. Understand? Now, and the second part of, before moving to the second part of principle of homogeneity, and look at here, and there is no rule for the division and multiplication of the physical quantities. To divide two physical quantities, the two must be, two may or may not be having same dimensional formula. My dear students, I hope you got the point. Not only for the division and for a multiplication also, if I write x into y, there are two physical quantities which we are dividing and which we are multiplying. And there is no condition that these two must have the same dimensions. It's not like that. Those two may not be having the same dimensions or maybe having the same dimensional formula. No confusions at all. Remember, only when you're adding two physical quantities and subtracting two physical quantities, there is a rule. What is that? These two must be having same dimensional formula. Understand? Clear? Listen. A very important thing which is very useful for your entrance point of view, I'm telling you now, listen carefully. If I write capital A is equal to B plus C by D. Look at it. There are four physical quantities here. For example, I am telling you. So this is the in-depth analysis of the principle of homogeneity. There are four physical quantities I have given here. A, B, C, D. Four physical quantities. One may be work, another one may be energy, another one may be a force, and the fourth one may be a velocity. Like that, four different physical quantities I have taken here as an equation. What you should understand, according to the principle homogeneity, the first thing, wherever you are adding two physical quantities, they must be having the same dimension, C. And just adding B and C by D. Now C by D is a physical quantity, understand? So this is one physical quantity, this is another physical quantity. Both if you divide, you will get another physical quantity, right? You may get another physical quantity, it will have some dimension formula. So now this B must be equal, the dimensions of the B must be equal to the dimensions of C by D. Listen. So the dimensions of B must be equal to the dimensions of C by D. Understand? This is the first part of the principle of homogeneity. And the second part is about equating. Right? Look at here. There are two parts involved in principle of homogeneity. And number one, the first one is about addition and subtraction. The rule, right? What is that rule? We know already. And the second part is about left hand side and the right hand side of the equation. So left hand side and right hand side of the equation. Whatever may be the equation. How many entities are there? So let's concentrate on this equation. In this equation, how many entities are there in the left hand side? X, dimensions of that X must be equal to how many individual entities are there in the right hand side. So this I can write A dimensions, that will be equal to B dimension. So from the first part of principle of homogeneity, you have already got A is equal to B dimensions. And the second part of principle of homogeneity tells this. Let's write the same. The dimensions of Y must be equal to dimensions of M. That must be equal to dimensions of N. Understand? And write this also. Dimensions of A left hand side, which is equal to dimensions of B, which is equal to dimensions of C by D. Okay. Clear? Understand? One more, the deep analysis point I'm just giving you. Listen to me carefully. Let's take this similar equation like this. Right? Similar equation like this. So what is that similar equation? Look at here. For example, A is equal to B plus C square by X. A, B, C are known quantity with dimensions. Quantity means it will have some dimensions. Okay. And X is an unknown quantity here. What is that? X is an unknown quantity here. So this is what the applications we are learning and the numericals we will be solving now. A, B, C are known quantities and X is an unknown quantity here. How to find this unknown quantity dimensions? That's a question. Okay. And the dimensions of this A, see here, dimensions of A can be equal to dimensions of C square by X. Can I write like this? Okay. If you know the dimensions of x and dimensions of c's, you can find x dimensions. How? Just to cross multiply this x dimensions into here and dimensions of c square by dimensions of a, you will get the dimensions of x. Just it is like a normal multiplication and division. But when you are adding or subtracting, you must follow the principle of homogeneity. For multiplication and division, it's common. If, see, for example, if this quantity is a force and this quantity is an acceleration, force dimensions and acceleration dimensions, so both division, you get the dimensions of an unknown quantity. Or you can also do in this way. Now we have taken this according to principle of homogeneity, we have considered this entity and this entity. Now let's consider this entity and this entity here. So the dimensions of B must be equal to dimensions of c square by x. Why? Because this entity plus this entity, there are two quantities we are adding. They must have the same dimensions. Here also the same thing. If you want to find the unknown quantity dimensions, so the dimensions of c square by dimensions of b. Alright? Clear? Just pause the video, listen or have a look at all the equations and the example applications, whatever I have written now. Then you will be 100% ready for the numericals, what we are going to solve now. My dear students, now you will understand the purpose of using principle of homogeneity, right? Look at here. Principle of homogeneity, it is used to check the dimensional correctness of an equation. It is used to check the dimensional correctness of an equation. What exactly I meant by that? Let's have a look at it. I'm just taking three examples, three equations. Number one, S is equal to ut plus half at square. Three equations. And number two, v is equal to u square plus at. And the third equation, v square minus u square is equal to 1 by 3 as. Right? Do not think about the incorrectness of the equations. The exactly speaking incorrectness means the physical incorrectness, because you have already learnt about a chapter called motion in one dimension. Like the basics, in basics we have learnt motion in one dimension. There, kinematic equations we had learned. Kinematic equations you know, but do not compare these equations with kinematic equations. Now, for time being. And they have clearly mentioned in all the three equations, the symbols have their own meaning, right? So what is that? So in all the three equations, symbols have their own meaning. Symbols have their own meaning. Okay. So what is meant by symbols have their own meaning? That means S is the displacement, U is initial velocity, T is time, A is initial acceleration, T is time, final velocity, initial velocity, acceleration, time, final velocity, initial velocity, acceleration, displacement, like that. Symbols have their usual meaning. Now, listen to me carefully. We need to check the dimensional correctness of each and every equation. Right? What we are going to do here is we are going to check dimensional correctness of the equation. All the three equations, dimensional correctness we are going to check. How we can check the dimensional correctness? By using principle of homogeneity. And let's start with the first one. S is equal to ut plus half at square. So, dimensions of S must be equal to dimensions of u into t, because this is an entity, understand? That must be equal to dimensions of half at square. Let's move on. Dimensions of displacement is L. Dimensions, see, when this equation is satisfied in this way, left hand side and right hand side, all the individual entities are having same dimensional formula, then you can say this given equation is dimensionally correct. Okay, so this must be satisfied. Let's see. Dimensions of displacement is L, and dimensions of initial velocity Lt minus 1 into dimensions of time is T. Okay, which is equal to dimensions of half. No dimensions for the numerical value, there won't be any dimensions. Acceleration, it's Lt minus 2 into t square. Okay, time dimensions t square. So this is L, which is equal to, this is L, t minus 1 plus 1. So t to the power 0. T to the power 0 is 1. So that's remaining is only L. Here also remaining is only L. Yes. So the given equation is dimensionally correct. Carefully see. The given equation is dimensionally correct. Understand? So can I say this equation is physically correct? Because from the kinematic equations concept, you already know that S is equal to ut plus half at square. So this equation is dimensionally correct and physically correct. Come back to the second example. In the second example, according to the dimensional correctness, the dimensions of this V must be equal to dimensions of U square must be equal to dimensions of A into T. Then this equation is dimensionally correct. Let's check. So V, velocity dimensions are Lt minus 1, which is equal to, this is initial velocity whole square. So that will be Lt minus 1 whole square. That is equal to acceleration Lt minus 2 into time t. So this is Lt minus 1 and this is L square t minus 2, just square, which is equal to Lt minus 1. Is it correct? This equation is not equal to this equation, understand? So this is wrong. It is wrong. If it is wrong, what can I write here? Like this. So can I say this equation is dimensionally correct? No, the principle of homogeneity is not satisfied. So this given equation is dimensionally incorrect. Dimensionally incorrect. Carefully see. So can I say this equation is physically correct? Physically correct? No. Impossible, because physical correct equation is V is equal to U plus AT. It's V is equal to U square plus AT. So I can say this equation is physically also incorrect. Alright? Alright? No. Dimensionally incorrect, physically incorrect. Move to the third example. Check the dimensional correctness of this equation. When it is dimensionally correct, V square dimensions must be equal to U square dimensions. I am writing the left hand side part. That must be equal to the dimensions of 1 by 3A into S. Velocity dimensions Lt minus 1 whole square, which is equal to U square dimensions LT minus 1 whole square, which is equal to 1 by 3 will not have any dimensions. Acceleration will have dimension LT minus 2 and displacement will have dimensions L. So this is L square T minus 2 will be equal to L square T minus 2 and that will be equal to L square T minus 2. My dear students, can I say this equation is dimensionally correct? Everyone must observe and understand. Can I say this equation is dimensionally correct? 100% we can say that this equation is dimensionally correct because the principle of homogeneity condition is satisfied. So I can write, so this equation is dimensionally correct. Now, my dear students, tell me whether this equation is physically correct or not. Physically correct or not. Physically means according to the kinematic equations, this equation is physically correct or not. Physical correct equation is v square minus u square is equal to 2a, yes, but it is v square minus u square is equal to 1 by 3 as. So this equation is physically incorrect. What is that? Physically incorrect. Here comes the important statement useful for your board exams. Important statement. Before moving to the statement, let's analyze these three examples. You can see wherever the dimensional correctness is there, the equation is physically correct here and the equation is physically incorrect here. Clear? Again I am telling you. Wherever you can see the dimensionally correct thing, two possibilities are there. The physically, the equation, given equation may be correct or may not be correct. Right? That means, it doesn't mean that when you get a dimensional correctness for your given equation, it doesn't mean that the physical correctness will be possible. I hope you got the point. They have given an equation. You check the dimensional correctness of an equation and it is correct dimensionally. But it will not guarantee you the physical correctness. May or may not. This is a real example here. This equation is dimensionally correct and physically also correct. But this equation is dimensionally correct, but the physical incorrectness is there. Physically it is not correct. Okay. So the statement is dimensional correctness will not guarantee the physical correctness of an equation. Understand? The continuation is also there. Listen carefully. This equation is dimensionally incorrect. Dimensionally incorrect, and this is physically also incorrect. Okay? Clear? Now, in any equation you focus. If it is dimensionally incorrect, definitely that will be physically also incorrect. Understand? Any equation you take. Dimensionally incorrect, physically also incorrect. For example, instead of writing this one, if I write an equation like, similar to that, if I write an equation like S is equal to U square T plus half AT square. If I write an equation like this, you check the dimensional analysis, the dimensionally it will be incorrect and the physically also it will be incorrect. So what I can write, a dimensional incorrectness will guarantee the physical incorrectness. And the students, I hope you got the point. The dimensional incorrectness will guarantee the physical incorrectness, but dimensional correctness will not guarantee the physical correctness. Okay, clear? So when the dimensionally incorrect equation you take, definitely it will be physically incorrect. Okay, so this is how you can understand the deeper analysis of the principle of homogeneity. Now let's solve few numericals based on principle of homogeneity. My dear students, let's have a look at three basic numerical on principle of homogeneity. Let's see the first one. The question is, equation is given. Energy is equal to half mv square plus mgh. Physically speaking, that energy is the total energy. It's called mechanical energy. Always the mechanical energy will be the sum of potential energy and kinetic energy. And its energy half mv square plus mgh. Alright. Question is, find the dimensional consistency of the equation. Dimensional consistency means the dimensional correctness of the equation you need to check. How to check the dimensional correctness? This entity and this entity they are adding. That means this dimensional formula must be equal to its dimensional formula. So that is equal to its dimensional formula also, because according to principle of homogeneity, left hand side how many entities are there, that individual dimensional formulas are equal to right hand side how many dimensional entities are there, those individual dimensional formulas must be same, right? So the dimensional consistency equation I am writing, dimensions of energy which is equal to dimensions of half mv square which is equal to dimensions of mgh. Okay, clear? Now dimensional formula of energy. So when final equation is satisfied like this, so that's called dimensional correctness of equation. Energy dimensions are ml square t minus 2. Again I am not deriving it, already we have done, which is equal to half mv square. 1 by 2 will not have any dimension, and this is mass and velocity. Velocity is lt minus 1 whole square. Okay, which is equal to m g lt minus 2. G is acceleration due to gravity. Okay, lt minus 2, and this is h. H is height l. So m l square t minus 2, which is equal to m l square t minus 2, which is equal to m l into l square t minus 2. Alright. So can I say this equation is dimensionally correct? Can I say this equation is dimensionally correct? Yes, it is correct. Okay. Clear? Come back to here. The question is, find the dimensions of this equation. E j square by m raised to 5 into g square in one of the KCT, JEE, NEET, any equation, any entrance exam you take in one of the years, this question or similar model was asked. Find the dimensions of a quantity. So the quantity is this one, E j square by m raised to 5 g raised to 2. Alright? Clear? Now, where E is energy, you know the energy dimensions. J is angular momentum. So the momentum dimensions you know, angular momentum dimensions you don't know. Keep it aside. M is mass, G acceleration, G, capital G is gravitational constant. And you know the dimensions of mass and the dimensions of capital G also you know. It is given that angular momentum is equal to mass into velocity into radius. So m is mass V is velocity and R is radius. Angular momentum formula is what? mvr, mass into velocity into radius. Again and again, I am not going to repeat the angular momentum formula. This angular momentum actually you will be learning in 6th or 7th chapter in your first PUC. But as I've told you already, this is the chapter called units and measurements. Units. Each and every chapter there will be few new physical quantities I will be introducing you in first PUC topics. So those first PUC and second PUC topics will have some quantities and they will have some units, and that also will be written here. Once I have told you, I hope you remember. NEET exam you are not going to write after first PUC or now. Clear? So you will be writing after studying 2 years of your first PUC and second PUC. That's why. As this chapter name is units, so lot of units are involved here. Don't get confused. That's the reason I have given the formula for this angular momentum. Mass into velocity into radius. Okay. So now all the dimensions you know. There is no principle of homogeneity is involved here because no multiplication, because there is no addition or no subtraction. Right? Now, energy dimension. See, start. Energy dimension. So what is energy dimension here? ml square t minus 2 energy dimension into j. What's the dimension of j square? So before that, so let's write the dimensions of j here. So j dimensions are what? Mass is m. So v is lt minus 1 and r radius means some length, right? So that is l. So dimensions of j, ml square t minus 1. Okay, ml square t minus 1, but that is j square, don't miss it, by m raised to 5. So that is m5 into g square. Dimensions of g, m minus 1, L3, t minus 2. I could remember this because so many times I have discussed about g. You also remember. M minus 1, t minus 2. Minus 1, minus 2, plus 3. M minus 1, t minus 2, L raised to 3. Remember it like this. So that is also whole square. Don't miss it. Understand? So this m raised to 5, this m, the whole raised to 5. No, write it once again. This is m L square t minus 2 numerator, and this is m square L to the power 4 t to the power minus 2 divided by m5 into this is m minus 2 L raised to 6, 3 square 6 t minus 4. Okay, let's write one by one. Numerator m square, that will be m cube, that means m3, L square L to the power 4, that will be L to the power 6, t minus 2, t minus 2, that will be t minus 4. That is the numerator, and denominator will be m raised to 5 minus 2, so that will be m3 L raised to 6 t raised to 4. Carefully if you see, numerator and denominator will have the same dimensional formula. So m3 cancels, L6 cancel, t minus 4 cancel, and you got it as m0, L0 and t0, and I can say the given physical quantity or an expression is dimensionless. So this is the expression, so dimensionless. My dear students, did you understand the concept? The given expression is dimensionless. The question can also be asked in this way. This expression they'll give, right? The dimensions of the given expression is equal to the dimensions of what? In the options it will be there. Again I'm telling you. The dimensions of the given expression is equal to dimensions of what? The given expression. Options will be force, mass, velocity, angle. Angle will not have any dimensions, understand? See here. Angle. Okay, like this questions will be asked. Now, one more. Given force is equal to A into T plus B into T square. A into T plus B into T square. So F is force here. F is force here. T is time here. Dimensions of force you know, dimensions of time here. Now the question is, find the dimensions of A and B. Find the dimensions of A and B. Alright. What I have told you, according to the principle of homogeneity, so when there is an addition is taking place, that means the dimensions of this entity must be equal to dimensions of this entity. Alright. Or dimensions of this must be equal to dimensions of this must be equal to dimensions of this. So according to the principle of homogeneity, what I can write, the dimensions of force is equal to dimensions of A into T, that is equal to dimensions of B into T square. Alright? Clear? Now, force dimensions you know and time dimensions you know. Let's take these two. Dimensions of force, ml square T, ml T minus 2 is equal to dimensions of A into dimensions of T is time. Okay. So simple. This dimensions of A is equal to mlt minus 2 by T. So I can write mlt minus 3. Alright. That is dimensions of A. Okay. Now, let's take these two. Right? So these two. What is that? These two if I take, it will be dimensions of force mlt minus 2, which is equal to dimensions of B into dimensions of T square. Okay, so dimensions of B will be equal to mlt minus 2 by T square. So that will be mlt minus 4. See here, dimensions of B and dimensions of A both we have got here. Dimensions of A and dimensions of B both we have got. Now the question is, find the dimensions of A and B. That's it. Sometimes the question can be asked, find the dimensions of A by B. A by B dimensions of what? A's dimensions are mlt minus 3 by B dimensions are mlt minus 4. So m cancel, l cancel. That I can write T minus 3 plus 4, and that is time dimensions. Dimensions of A by B is equal to dimensions of time. Let's concentrate this space now by understanding a small concept. X is equal to, that is the quantity, X is equal to A into M divided by, look at here, Z plus B. Even in this case also, this dimension must be equal to this dimensions. And one more very important point I am telling you. Wherever the addition or subtraction is going on, that may be inside equation given, inside an entity given, right? Inside an expression given, wherever it may be. Wherever it may be, there is an addition going on. I can say the dimensions of that Z is equal to dimensions of that B. The example quantities and the letters I have considered. Remember that, a very important thing. If this is an equation, these dimensions must be equal to these dimensions, but there is an addition going on somewhere in the expression. So that quantity dimension must be equal to this quantity dimensions. Alright? Clear? And its sum also will have the same dimension, right? Its sum must be having the same dimensions of this or this. Okay? Clear? My dear students, the last numerical of the session is this one. This is the frequently asked model for your competitive exams based on dimensional analysis, especially principle of homogeneity. Let's look at this. The question will be asked in this way. The potential energy of a particle varies with the distance x. So, x is the distance. Wherever you see in this numerical, x is the distance from the fixed origin as. So, according to this equation, the potential energy is U varying with x. So, the concept behind this equation doesn't matter to us now. That comes under potential energy topic. That comes under work energy power topic. So the question is, potential energy of the particle is varying according to the distance x. So U is the potential energy. X is the distance. Where, see, the equation is U is equal to A root x divided by x square plus B. And this is the equation. I am writing it as U is equal to A into x to the power 1 by 2. Because root x, I can write it as x raised to 1 by 2. So this is x square plus B. Where A and B are dimensional constants. Means their constant will have some dimensions. Okay? A and B are having dimensions. What is the dimensions? We will be writing after finding them. Then the dimensional formula of AB, the product. So this product will have what the dimension? That's a question. Alright. You just find the dimensions of A and dimensions of B, then multiply it, you will get the answer. Clear? Look at here, my dear students. Whatever may be the expression, I told you clearly, whenever there is an addition or subtraction is going between, it's happening between two physical quantities, just their dimensions must be same. Look at here in the denominator, I could see these two quantities are adding, means the dimensions must be same. So I am writing here, from the denominator, what I could see here, as per principle of homogeneity, what I can write, the dimensions of this x square dimensions must be equal to dimensions of B. Alright. X is the distance. Distance will have the dimensions length. So the dimensions are L square, which is equal to B. Finished. The dimensions of one physical quantity we need dimensions of two quantities. One is L square. Understand? Look at it. So simple. From this denominator I had focused. So dimensions of B is how much? L square. So that means M0, L2, T0. No confusions. Alright. Focus on this. How to focus on this and what to do now. Carefully see. This equation I am considering now dimensions of U, energy, potential energy, whatever may be the energy dimensions, ml square T minus 2, alright, which is equal to, what is this A? A dimensions we don't know, that is our aim. X dimensions we know, that is L 1 by 2, because L to the power 1 by 2. By, here comes an important part here, carefully see. This is the sum of these two quantities. Sum of these two quantities will have some value, will have some quantity. That quantity also must be having the dimensions of this or this. Yes or no? Yes or no? Listen once again from this part, example I am writing here. If I write a square plus b is equal to a square plus b is equal to y, for example, according to principle of homogeneity, this y must be having dimensions of a square, that must be having the dimensions of b. Understand? According to principle of homogeneity, will you agree this? So we are adding these two quantities. You will get another quantity that will have the dimensions of this or this. So I can say the sum will have the dimensions of b. Okay. The sum will have the dimensions of x square. Both are same. So what I can write, the sum in the denominator will have the, I am writing the dimensions of everything. Dimensions of this I wrote, dimensions of this I am going to find out, dimensions of this I wrote, instead of writing dimensions of this and this. So the sum will have the dimensions of this, dimensions of b. Okay. Or dimensions of this, L square. Everything is fine. From here, I can write ml square t minus 2, which is equal to a L to the power 1 by 2 divided by dimensions of b is L square. Alright, dimensions of b is L square. So this is dimensions of a, I need to find out. Just cross multiply this L square. For multiplication there is no rule. For division also there is no rule according to principle of homogeneity. Understand? Just multiply this L square here. So if I multiply ml square t minus 2 into L square, which is equal to a into dimensions of a into L to the power 1 by 2. Okay. Here m L to the power 4 t minus 2 divided by this L to the power 1 by 2 also bring to the left hand side. So that is equal to the dimensions of A. So finally the dimensions of A will be how much? Look at here. M L to the power 4 minus 1 by 2, because this L to the power 1 by 2 goes to the numerator, that will be L to the power minus 1 by 2. So that will be 4 minus 1 by 2 into t to the power minus 2, which is the dimensions of A. Finally, this is m, this is L to the power 4 2s are 8, 8 minus 1, 7, 7 by 2, t minus 2. Alright, so let me write the dimensions of A here. Tell me the dimensions of A, everyone, tell me the dimensions of A. M, L to the power 7 by 2, t to the power minus 2. But the question is, find the product of A and B. Product of A and B. Let's do the multiplication of this A and B. A. ml 7 by 2 t minus 2 into b L square. What is that? ml 7 by 2 plus 2 t minus 2. So what is that? L raised to 2 2s are 4, 7 plus 4, 11 by 2 t minus 2. So that is the answer. This is the answer. M, L raised to 11 by 2 t minus 2. This way the numericals will be asked. See, in the first class we have not discussed this question. After 3 or 4 classes based on dimensions, we have discussed this question. That's called learning from the basics to the advanced level. And some more advanced level is left. So that will be discussed in the next sessions. Those questions are also called frequently asked questions in competitive exams. All the very best. Get ready for your assignment now.